All right, solving absolute value inequalities is our learning target. The warm-up today is on the previous learning target, so if you'll pause this video, give you time to solve it, then you can come back and check your answer, and if you have questions, you need to come ask. Check your answer. Make any corrections that you need to. If you're still unsure, you need to come ask me. Absolute value inequalities. So this is where we're going to marry what we did with absolute value equations and what we did with inequalities, and it's all shown up in one problem. Okay, so remember absolute value bars being like distance, and we saw previously that that would typically could have two answers. So we're going to split this up into two inequalities. So we write down, and of course those need to be isolated. And then for the second one, we're going to switch the inequality and change our sign. So now when we look at that number line, so for this one, open or closed? Open. Pick a number that could go in there for x to make this true. So like 2. Point towards that 2. Then if we look at this one, at -4, open, greater than, so it's pointing this way. Okay. Notice I did not misspell this word up here. Okay, less than. It means that it's going to look like an and compound inequality where the arrows go towards each other. Okay, and that kind of gives you a little preview on what that's about. Great tour. Again, I did not misspell it, just kind of playing on words here to help you see. So if we were going to solve this one and we split this up, and that comes from the inequality, so the absolute value of x is greater than 4. So again, if we were to split that up into 2, switch the inequality and change the sign, and we look at that number line. This one's open again. Pick a number that would fit in there for x. 5, 6, 7, so it's going to go that way. And then for -4, open, circle. Pick a number that would be less than -4. -5, -6. So again, if it's the inequality here is greater, so this right here, oops, I didn't mean to do that. If this little symbol there is greater, it's going to look like an or, where the arrows go out from each other. Alright, we're going to try a couple problems here. First one, the absolute values are already isolated. Yes. So we can go ahead and write our two inequalities. Switch the inequality and change the sign. Solve each one individually. So we're going to add 12. Divide both sides by 3. It's not a negative, so we can keep the sign as is. Greater than 6. Come over here and do this one. And then we're going to graph that on a number line. We'll say that's 2, and we'll say this is 6, okay? So if I were to look this one at 6, open or closed. Also, you can tell right here it says 3x minus, the absolute value of 3x minus 12 is greater, so hopefully you can predict how these arrows are going to go. Then 6. Again, I would pick a number that would go in here for x that would be larger than 6, so 7, 8, 9. We're going to go that way. We're going to look at this one at 2, open or closed, close. Pick a number that could go in there for x and make it true, so x is less or equal to 2, so like maybe 1, -5. And it kind of follows that pattern that I set out. Remember, grade tour, arrows go away from one another. All right, let's look at problem 2. The absolute value is not isolated, so the first thing we must do, always, isolate the absolute value bars. So what we're going to do here is we're going to subtract 6. And now I can finish this problem out. Split them into 2 inequalities. Remember the second one, change the inequality and change your sign. Alright, so go ahead and finish this one out, and then you can pause, finish this one out, and come back and see how we did. Alright, so if you were to look at your answers, check. Okay, and then this one is less than, right? So you should kind of be able to predict how these arrows are going to look for your graph. Less than, so the arrows should be going toward each other. I'm going to go ahead and put the number line up here. We'll say this is 8. I'll put -4 here. So if I were to look at less than 8, open or close? Open. But I'm not sure why that did that. Open circle, because there's no line underneath that inequality symbol. Pick a number that could go in there for x. Then we're going to do the same thing for the -4, open or close. X is greater than -4, so 2, 3, 5. There we go.